For this video, we're again looking at how to evaluate limits analytically, but there are square roots. So the very first step would be to take the 0 and plug it in. So 2 plus 0 is 2. The square root of 2 minus the square root of 2 is 0 over 0. So again, we have a removable discontinuity. Now it's important to say that if you got 0 over 4, 0 divided by 4 is 0. That's your answer. Just write it down. If you get 2 over 4, your answer is 1/2. Just write it down. I'm just dealing with the more complicated limits. So what we're going to have to do is figure out how to actually remove the discontinuity. Now since I plugged 0 into both the numerator and the denominator and I got 0 over 0, I know that 0 is a 0 and x minus 0, or just x, is the common factor. The problem is that the x is very obvious in the denominator but not in the numerator, so you have to learn how to deal with that. And y'all learned how to simplify radicals in previous classes, expressions with radicals. So I'm going to do that here, and I'm going to multiply by a very clever form of 1. What I'm going to do is multiply by the conjugate of this expression here. And if you remember, a plus b times the conjugate, which is just a simple sign switch, a minus b, equals a squared minus b squared. Because your middle terms, a times b and a negative a times b, cancel out. So what's going to happen is I'll square the first, that'll get rid of this square root. I'll square the last, that'll get rid of this square root, and the middle terms would just cancel out, so I don't have any square roots left. So the conjugate of this would be the square root of 2 plus x plus the square root of 2, and since I have to multiply by 1, I have to multiply by the same thing in the numerator and the denominator. Okay, now this becomes a big distribution problem. Remember, when you multiply straight across. So again, first times first, the square root of 2 plus x times the square root of 2 plus x is very simply 2 plus x. You're squaring the square root. If you look at this, the negative square root of 2 times this, and then the positive square root of 2 is the same thing. Those cancel out. Look at last times last, and negative times a positive is negative, and the square root of 2 times the square root of 2 is very simply 2. Now in the denominator, I'm not going to work this in. I already know that my common factor should be an x. I'm not going to distribute it, then have to factor it out to cancel. So I'm going to say this is x times the square root of 2 plus x plus the square root of 2, and I'm taking the same limit as x approaches 0. And this has the same problem that this one did. It still has the whole. But if you look at my numerator now, I have 2 plus x minus 2. The 2's cancel out, and I'm just left with an x. And now you can see the common factor. We have x over x. I'm going to cancel those out. It leaves a 1 in the numerator. So this is equal to the limit as x approaches 0 of 1 over the square root of 2 plus x plus the square root of 2. So now I'm going to take my 0 and I'm going to reevaluate this limit. So if I plug in my 0, this is 1 over 2 plus 0 is 2, so the square root of 2 plus the square root of 2, which is very simply equal to 1 over 2 square root of 2. And you do not need to get radicals out of denominators in this class. Nobody cares. A square root in the denominator is absolutely fine. Okay, so another example. I take the 3 and I plug it in. 3 plus 1 is 4. The square root of 4 is 2. Minus 2 is 0. And then 3 minus 3 is 0. So, again, I have a removable discontinuity. I got 0 over 0, and I'm going to have a common factor. Now, since 3 gave me 0 over 0, I know that x minus 3 is the common factor, and you can see it in the denominator. Well, that means I need to change the way this looks, and there is a square root involved, so I'm going to do the same exact thing I did before and multiply by the conjugate of the part of the expression with the square root in it. So I'm going to change this sign right here. This will be the square root of x plus 1 plus 2 over the square root of x plus 1 plus 2. Okay, so this will equal the limit as x approaches 3, and then again, if I do first times first, square root of x plus 1 times square root of x plus 1 is very simply x plus 1, and negative times a positive is negative, and then I have 2 times 2 is 4, over I'm not going to distribute my x minus 3 in. I know it's the common factor. It will cancel, and if you look right now, you can see it. X plus 1 minus 4, all of this is an x minus 3. So that's gone. And I'm left with this times this in the denominator. If I look at it, I can now remove my discontinuity, cancel out the x minus 3's. I'm left with a 1 in the numerator, so I'm taking the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. And I can just evaluate my limit. So I take my 3 and I plug it in. 3 plus 1 is 4. The square root of 4 is 2. 2 plus 2 is 4. This equals 1/4. And I'm going to do one more just to make sure we're all understanding. The limit as x approaches 4 of x minus 4 over the square root of x minus 2. So I take my number and I plug it in. 4 minus 4 is 0. The square root of 4 is 2 minus 2 is 0. So I have a common factor, and I know what it is. It's going to be an x minus 4, which this time you can see in the numerator. Since there are square roots involved, I'm going to multiply by the conjugate of the expression with the square root. So I have the square root of x plus 2, square root of x plus 2. So when I multiply, this becomes the limit as x approaches 4. And again, I'm not going to distribute these in. I'm just going to write it down. I know my common factor is x minus 4. So I'm just writing both of the product of both of them. Divided by first times first is just an x. The middle terms again cancel out. And last times last is a negative 4. And you can see right here they cancel out. So this will equal the limit as x approaches 4 of the square root of x plus 2. I take my 4, reevaluate the limit. Square root of 4 is 2 plus 2 equals 4. And that would be the answer.